Hello everybody and welcome back to 3DAF. My name is Zander and today we're going to be jumping right back into G-code programming with motion codes. That's your G00, G01, G02, and G03. So let's get right into it. So what are motion codes? Well, motion codes are used to move the machine and they utilize a Cartesian coordinate system with a minimum of two axes, X and Y typically, but can also include Z, A, B, and C. They maneuver the tool to the position that it's going to do work, whether it's cutting or adding material. All motion codes will move from the current position that the machine is at to the new position of the code simultaneously by using the motion defined within the code. And major motion codes include G00, G01, G02, and G03. G00, which is rapid movement, is used for moving around the machine while it's not working to get to the place where the next code is going to start. Typically when this happens, the machine will retract a little bit and move away from the workpiece to make sure it stays clear and it's not going to hit anything while it's moving around. It will move at the machine's maximum feed rate, and it will move all axes simultaneously. And the way to think of G00, that is your highway speeds. You know, that is jumping on your autobahn and putting the pedal to the metal. So, now what is feed? Feed is the speed in inches per minute, IPM, or millimeters per minute, MMM, that the machine will move. And what is working? Well, working is anything that the machine tool is going to be doing, whether it is cutting, burning, torching, laser cutting, adding material, EDM, the whole shooting match, that is working. And now we're going to talk about G01, or linear interpolation, which is used for straight line movements when working, whether that is along an axis or if it's on an angle. It's controlled by the F word, or feed, and the feed for a motion is set by either the maximum resolution movement of the machine or the working speed for the material and tooling, whichever is lower. And now, I'm sure you're wondering, what is machine resolution? Well, machines are typically controlled by a stepper motor and stepper controller, which can only move smoothly at specific feeds as they have a minimum step over. Angular and circular motions are made by moving two or more motors in a micro-stepping motion, creating little L-shaped patterns that is relatively unnoticeable at the proper resolution. If you're seeing stepping in your finished part along the line of motion, you've exceeded the maximum machine resolution. And now our final two codes go together, that is G02 and G03, also known as circular motion. These are the turn signals for driving the machine, and they'll determine which direction the machine will turn, with G02 being clockwise motion and G03 being counterclockwise motion. Now, these codes can be controlled with an R code, which is the radius which it's going to turn, but this can only be used in arcs of less than 360 degrees. If you want to go more than 360 degrees, you will have to use the I, J, and K method, where I, J, and K arguments determine the distance from the arc start point to the arc center point, I representing your X offset, J representing your Y offset, and K representing your Z offset. Now an example of how we'd use these codes within a program to create a shape. Keep in mind that there would also be opening, closing, and tooling codes in a conventional program. We are going to start off at x-2, y-2, and wrap it over to the start position at x0, y0, so G00, x0, y0. Then we will use a linear interpolation to work up the wall, G01, y2, f50. You may have noticed that I did not put an X code in, that's just because the X didn't move. Now that we are at the next pivot point, we will use another linear interpolation to move to the beginning of the arc, G01, x2. In this line, we did not need an F code, as the feed did not change, and we will not be changing it throughout this program. This has put us at the beginning of the radius. We can see that the radius is clockwise and 0.5 inches, so we will add G02, y1, r.5. This has moved our tool around to the bottom of the arc. Now, we will need to move to the beginning of the next arc with a linear interpolation, G01, x1.25. We will wrap around the counterclockwise arc with a 0.25 radius, G03, y.75, r.25. Back down to the bottom corner now with a G01, y0, and then finally back to our working start point with x0. We did not need to put a G01 as it is modal and stays in effect until cancelled or overridden. And finally, we'll pull away from the part, completing it with a G00 x-2, y-2. Now, just a quick note, this example assumes that you are using tool compensation, but that is a topic for another day. Alright, so that wraps up our episode on motion codes. Hopefully you've learned something new that you can bring away to your hobby, work, or wherever you're going to use those G codes. If you like this content, make sure you like, subscribe, hit that notification button, and if you've missed any of our prior episodes, we've also done one on the basis of G-code programming and M-code programming. I'll have a link to at least one of those up here. Thank you. Have a good rest of your day.